everyone, and welcome back to what is already our seventh track today and sharing during Big Data Days. We're going to be listening next towards one of my favorite topics, which is artificial intelligence. And today I have with me an expert who is going to share his knowledge around how AI is the new electricity. Our speaker for today is Surendran Selvaraju, who is a data scientist at AINQA Healthcare. A trainer in natural intelligence solutions and experienced analytics specialist who has a demonstrated history in working in the industry and with a variety of domain exposure into fields as biology, telecommunications, and oil and gas. Surendran has a very strong analytic practical skill set developed with analytical models and predictions for several projects. Surendran is skilled in data science, Python programming, and algorithm design. Equipped with a strong knowledge in machine learning algorithms and strong IT professional skills, having a master's degree in machine learning from Multimedia University. I'm very much pleased to welcome Surendran for the first time on Big Data Days and sincerely look forward to his presentation. Welcome, Surendran. I'm very happy that you are able to join us later this evening for your time in Malaysia.
Thank you so much, Ms. Jane. Mr. Jane Willem. Okay, without any further delay, let me start with today sharing, I would say. So I'm going to share about AI is the new electricity. So it has been a question for all of us, like, what is AI? How does it evolve over a period of time? And what does it mean to you and me? And what does it hold for us in the future? Right? So before we go into what is artificial intelligence, let's be say like how our brain functioning. So it's let's say you were to wake up at 5 a.m. You require an alarm clock. So this maybe is like a training process for you, like for the first few weeks, right? So after a few weeks, you realize that you do not need an alarm clock anymore. Your body or your mind will be wake up at 5 a.m. So this is how your brain processes. This is how your brain function. You need to train it a bit, and then after a few time of training, it become self self function where it realizes by itself. So that's how our brain function and how it relates to AI. Similar to what or on how our brain function. That is how AI is actually a process of making machine to think how a human or like human. So that's what AI, artificial intelligence. And as the hype around AI, which has accelerated, I can say people or organizations has been scrambling to promote how their products and services using AI. Most of them, they refer to AI as a simply one component, which is machine learning. Okay. AI is a large scope. Machine learning is just one part of AI. You have a lot of other scope as well. And AI requires a foundation of specialized hardware and also software for writing and also training machine learning algorithms. Often, organizations or employers, they want to implement, they are so keen to have AI to be incorporated into their businesses. But then they hesitate to actually to finance on the special on the hardware and also the software, because we know that AI needs high speed computer, or I can say high end computer, in order to execute it, in order for you to train the model. AI is not just a simple programming, it's actually more towards it. And for AI, there is not only one programming languages. There are few, including the famous one, I think most of you know, which is Python, R, and Java. So in general, AI system work by admitting large amounts of labeled training data, analyzing the data to find the correlation and also the patterns inside the data. And then we use these patterns, or AI use this pattern to make prediction about future states. So in this way, for example, a chat box that is fed example of a few millions of text chats, and this chatbot will learn to produce live-like exchanges with people. Or you can see the AI application in image recognition too, which can learn to identify and also describe object in images by viewing millions of examples. Basically, I can say that AI programming focuses on three cognitive skills, which are learning, reasoning, and self correction. So, learning process for this aspect, AI programming or artificial intelligence focus on acquiring data and creating rules for how to turn the data into actionable information. So this rule we call this rule as algorithm. It provides computing devices with step-to-step instruction for how to complete a specific task. And when I mention programming, it's not a normal programming. When you just you have a rule-based programming, you just tell it if this condition, you do this. Okay, for example, if condition is A, then do B or else C. That is just a rule base, and if you're gonna write that for to make your system intelligent, it won't be intelligent because it won't have a decision making skills. I can say that because it only follow the rules that been defined by you. It's different from AI, where you use machine learning. The decision is made by them. They learn from their mistakes. So that's why we call it a smart or intelligent system compared to the normal programming. This is the man called John McCarthy. He was an American computer scientist and cognitive scientist. He's the one who coined the words or the phrase artificial intelligence. And he also was one of the founders of the discipline of artificial intelligence. And when it comes to AI, we have two group of AI. We often neglect this, or I can say that we are not aware of this. The first group is we call strong AI, and the second group we call it as weak AI. So I'm going to talk about weak AI first. So weak AI is also called narrow AI with limited function. So that's why you call it narrow AI. And weak AI refers to the use of advanced algorithm to accomplish specific problem solving for reasoning tasks which is not contain the full range of human cognitive abilities. For example, the tasks that use weak AI will be the voice-based personal assistants such as Siri and Alexa. And weak AI is also not so enthusiastic about the outcomes of AI. It's simply a view of intelligent behavior that can be modeled and used by machine to solve complex problems and tasks. But just because a system or a machine can behave intelligently, it does not prove that it is actually smart in a way a human is. So this is best example of weak AI that I can give you, which is Siri, Alexa, and Google search. So on the other hand, if you see that strong AI is a theoretically form of machine intelligence which supports the view that machine can really develop human consciousness equal to human being. So normally, strong AI refers to machines or programs with the mind of their own and which can think and accomplish complex tasks as their own without any human interference. So they don't need human to tell them to do this and that. They're able to make their own decision and they're able to make sense out of it. And strong AI has complex algorithms that help system act in a different situation and the strong machine can carry complex tasks in their own, just like how human beings does. And this strong AI is simply the states that a computing machine with the appropriate functional organization has a mind that can perceive things and intents like a human mind. So this is why we have this AI, or you can see the strong AI in the most of the sci-fi movie like Her, The Terminator, I Robot, Wall-E, and more. Then come back to artificial intelligence. We have a strong AI and weak AI. Now we have other phrase that we all often confuse with. For example, artificial intelligence, machine learning, and deep learning. So artificial intelligence is actually the concept of creating smart, intelligent machine. Whereas machine learning is a subset of AI, artificial intelligence, that help you to build this AI-driven application. So artificial intelligence is just like a big umbrella. Under the big umbrella, you have a subset called machine learning. And this machine learning is actually a method, or I can say a process to help to build this artificial intelligence system. And under this machine learning, we have deep learning. So deep learning is actually a subset of machine learning that use vast volume of data and complex algorithm to train a model. So deep learning is like a one of the method in machine learning that used to develop artificial intelligence system. And in AI, we have three groups. The first group, we call it speech recognition. Second group, we call it natural language processing. And the third group, which is the last, pattern recognition. So they have a lot, but this is the main group that I'm talking about. So speech recognition, it is also known as automatic speech recognition, ASR, or computer speech recognition, or you can also call it as speech to text. Speech recognition is actually a capability of a system which enables a program to process human speech into a written speech or written format. And it's often or commonly confused with voice recognition. For natural language processing, it concerns with giving computers the ability to understand text and spoken words in much way the same as human beings. So for a computer to process like us, I mean, we hear phrases or sentences, we able to comprehend. But for computer, no, they don't have the brain like we do, right? So we need to develop a complex algorithm that can learn in a way of human understand languages. For example, like to mark a subjective question answer is not as easy as how we marking. The computer need to understand the semantic between the words, between the sentences. We have compound sentences, we have singular sentences, we even have negation like not and everything. So in order for the computer to understand the semantic relation between the sentences, it takes a great deal of process, a great deal of mathematics involving to build algorithm behind it. And the last group here will be pattern recognition. So pattern recognition is a data analysis method that use machine learning algorithms to automatically recognize the patterns and also regularities in the data. So this data can be anything ranging from text and images to sounds or other defined qualities. Pattern recognition system can recognize familiar pattern quickly and accurately. Another pattern recognition function, it can be, for example, devices that help the visual impaired people, or or visual challenged people. When they want to go to find a buses, these devices able to estimate the time taken for the buses to come, what is the distance between this person with the buses, and then where is the road of the buses, or the destination of the buses. And then when the person or the blind person board into the bus, it able to detect where in the buses the seat is empty. So all this involving object detection, and from the object detection it able to vibrate and to give signal to the impaired challenge people, in order to facilitate the daily routine life of impaired challenge people. Then from AI, when I mentioned just now, we have a subset we call machine learning. So machine learning is a program that learns from repeatedly seeing data rather than being explicitly programmed by humans. So once you program this algorithm, you don't have to program it again and again. You don't have to mention the rules again and again. It will learn by itself from the data. So you just give the data and it will learn the pattern from the data. What I'm saying here will be simple, but to implement it, it's not as simple as it is. Right? So if you just use programming and rule base, you need to define the rule base every time. And when every time there's a new data come in, then you need to define a new rule. So in algorithm, when you use mathematical statistic algorithm, you don't have to do that. The machine will learn by itself. So this example here, we have emails. We call label emails. That means we have the output and the example of output. For example, here we have email and it is labeled as spam or not spam. And then we feed this bunch of email to machine learning, and this machine learning will learn all the characteristic of spam email and not spam email. Then when there is a new email coming, this machine able to make decision or able to classify this new email as spam or not spam, based on, or I can say, on the based on the previous learning that we provide to the machine. And for machine learning, we have of two type of group. We call it as supervised learning and unsupervised learning. So for supervised learning, you need to have label data. Label data is the same as the first example I gave you, where you need to have output and the you need to have input and the desired output, right? So you have email, you want your program to able to automatically label email as spam or not spam. So you need to have email and respective label, for example, spam or not spam. That is supervised, come from the word itself, supervised. That means it means supervised. You need to have example output, and then you teach the algorithm, and the algorithm will be able to make decision or able to classify for a new email. And the second one is unsupervised learning. So the special about unsupervised learning, you don't have to label the data. I mean, the data is without any output, any desired output. When I say that you don't have label data, doesn't mean that it is not label data. Supervised learning have different function. Unsupervised learning have different function. Supervised learning is more toward classify. When you see a text, when you see an email, you say it's spam or not spam. Whereas unsupervised is always involving with clustering. That means it cluster the same group of people together, or same information together, or same data point into a separate group with same characteristic. For example, like customer segmentation, based on the customer demographic, social demographic, account balance, last transaction. I'm talking about a bank account data. So you can classify, or you can segment these people or this customer into several segments based on all these attributes that I mentioned just now. Okay, maybe what is the significant for me to segmentize customer? This will be very useful for you to have a target marketing. For example, if a bank would like to offer an insurance and he or she shouldn't call the all, let's say for example you have uh, around 20,000 customer. You don't have to call 20,000 customer. It's not efficient and you waste resources. It's costly, right? So to have more effective target customer, you do customer segmentation from all the attributes and the purchase of insurance from last time. You'll be able to have or to cluster the customer into the same segmentation, and maybe you have the first customer segmentation which have higher potential to purchase a new insurance. So you just call the target customer segmentation. Maybe based from the 20,000, you reduce it into 200 customers. You just only need to call 200 customer instead of 20,000 customer, right? So that's more efficient. That's why that is the use of unsupervised or clustering. In machine learning, when I mentioned just now, we have deep learning, right? So deep learning, it's a it's one of the method in machine learning, but it's more advanced method. And the idea is from our brain, because our brain we have several neurons, millions of neurons, and it connected, and it's how information pass to the neuron, and then to our body for reaction. So same goes here. We have a neural network where it has a lot of hidden layer, and hidden layer we have neurons. Neurons will pass information. Of course, it don't pass like our brain, but it has mathematical function we call activation function, which able to calculate and that summarize the weightage or the probability for the machine to take an action. This is example of how one neuron calculation, right? So you have way, input, activation function, and then finally it will calculate what is the most likely output it should be. And this is just one. Imagine if you have this. This is not really complex. You have more complex neural network than this. So this is deep learning. So that's why deep learning need great amount of data, and of course a good computer, this high-end computer in order for it to work. And when it comes to deep learning and machine learning, it's most often let people say, please do deep learning. So just to follow the cutting edge tools or cutting edge technologies, it's not correct. Like if you can have a good result by using conventional algorithm like other algorithm, the conventional algorithm like super vector machine, support vector machine, naive Bayes, or as simple as rule based, it gives you a good output and align with your business value. I mean, it improves your business value. So why not? You just use that. You don't have to use sophisticated algorithm, but ultimately it doesn't fulfill your business requirement, and it doesn't improve your business value, and it will become another algorithm or another system stack in the shelf not using. So that's called the field of data science or data analytics department in most of the company. And apart from it, why when people question why we need vast data amount of data in order to train deep learning, because this, can you see, you can see that is we have dog here. Okay, I think it's Chihuahua and the muffin. So it's almost the same. The computer, the system get confused. Which one is Chihuahua? Which one is the muffin? It looks almost the same, right? So in order to get a great deal of high accuracy, then you need to train it with quite a number of images in order for it to produce highly accurate classification. And same goes here. If you do the face recognition and it able to detect another face at behind. So this is the AI breakthrough, but it's the old one. It's in 2015 and also 2016, where computer can be trained to perform better on as human. And in 2016, there's a neural network where the performance of computer or algorithms nearly to human intelligence. And about 100 years ago, this is from Andrew Ng, Stanford University. He mentioned that about 100 years ago, electricity transformed every major industry. AI has advanced to the point where it has the power to transform every major sector in coming years. That's why you see everywhere AI is transforming every domain: education, healthcare, oil and gas, telecommunication, retails, HR, a lot more. And you can see the revenue from the artificial intelligence software market worldwide. It's increasing, and it's speculated that on 2025, it is more than 100 billion US dollar. Okay. Then guess what AI technology is for? Because you know AI technology, you know that we have under AI technology we have machine learning. Under machine learning we have deep learning, and you know that AI we have weak AI and strong AI. And now where is we use AI for? Okay. AI, you can find it in transportation. In transportation, I can say navigation, your GPS, your Waze, right? It able to predict what is the optimum time for you to go out in order to avoid traffic congestions. So how this they able to do this? They able to do this by analyzing your data, your previous. I mean, not just your data, with a lot of people data from the previous, or I call historical data, travel data, and from there they can suggest you that you can go out this time where the congestion is low. And it's also able to find the faster road by processing traffic data. And ride sharing like Uber that we know, it able to predict a real-time demand, like what is the demand of people in this particular vicinity or area, and the rider can stand by there so that they can get customer. And AI also present in social media. This is especially in Facebook and Twitter, where you can see there's whenever you talk to someone unknown, and then finally when you go home, there's a friend suggestion there come out. Okay, this is the near friends suggested friends. That means the AI know that you just met these people a few hours ago, and they are suggesting you this is the friends that you should add. And then if you upload your photo with a group photo, it able to tell you, please, would you like to tag your friends so and so based on the facial recognition, or I can say pattern recognition. So from the facial of your friends, it able to match your friend list, and then suggesting you should tag your friends as well. Right? And content, image recognition, and sentiment analyzed to ensure the content of appropriate mood is being served. So this one I can tell you a lot. For example, like campaign, right? So when you have your Facebook posting a lot of things, people can crawl the data and then know that what kind of person are you. They can even classify your personality based on your post, right? We have big five personality like consciousness and the four I've got. There's a big five traits. You can classify them, and then you can do a more effective business advertisement, right? And you can even study at what time best reception of news by people based on social media. You can know that at what time is the best for you to post or to advertise your product or services. Why is that so? Because if you post at early in the morning, or you post at during peak working hour, there's a lot of people posting the same thing, right? So your feed will be masked by other people, or will be pushed to the bottom. So it's like not effective, your campaign or your advertisement, because people like they don't even scroll down, because there's a lot of other things to look. They will just might overlook your advertisement. So in order for you to have effective advertisement, you will study how people behavior in social media. What is the optimum time that people use social media is the best for you to advertise your product or services. So in daily lives, you can see natural language and also object detection. For example, here, this is surveillance capitalism. Surveillance capitalism is the use of your private data and then manipulate you so that they can sell things to you. For example, like you want to buy something like shoes. For example, you have old shoes, then you're talking to your friends, you have, I have old shoes, then you try to google some of the shoes prices, then surprisingly you will see there's advertisement shoes. It just personalized for you in your facebook, and then whenever you browse anything, so this is kind of manipulation. They manipulate you so that, from the idea of buying to the action to buy, so that you really buy it. Whenever you open anything, the advertisement will only based on shoes. So that's I call that's the sorry, no, not I call that is the word called surveillance capitalism. So surveillance capitalism describe a market-driven process where the commodity for sale is your personal data, and the capture and production of this data relies on mass surveillance of the internet. Okay, so now we go for the next AI application, which is in agriculture. So you can see that AI have massive application in agriculture, it especially for the micro and also macronutrients in the soil, which is critical factors to crop health, to for the crop health, and also both for the quantity and quality of yield. Then, once these crops are in the soil, the monitoring of stages of growth essential to optimize production efficiency. So all this monitor, rather than done by the farmer, is done by the AI. AI is actually this can we can say that AI, this AI system with IoT, robot, and machine learning combined together to ease or to facilitate the work of farmer, and then to yield more production in the crops. And this is the robot or AI system which able to identify the wheat, specifically wheat, and then spray the pesticide only on the weeds, not on the crops, right? So when you use this system, when the farmers use this system, it able to save costs. So you don't have to spray pesticide all over the crops, and then when you spray pesticide, it might bring harm to one's health and consume the vegetables. But with AI system, it only able to spray pesticide only on the weeds. And to other extent, there is even a robot being built where it able to only pick the weeds. It weeding. It pull the weeds, which is it able to distinguish the crop and the weed, and then pull the weed without need to spray pesticide. So this you can get more better vegetables without any pesticide, since you have a AI system which able to do weeding. And then you have bugs, finding bugs with code. This AI system able to calculate how many bugs in your crops and what type of bugs. So it able to detect. So you able to take a precaution based on this. And also once you know what is the count of bugs, you can also get ready with your what kind of precaution that you want to have. And then you have livestock health monitoring. So animals is another major component of our agriculture system, and animal tend to need a bit more tracking than plants. So with computer vision or AI system, you can keep up with cows, chickens, and pigs on the move. Well, if a system can track all this, computer vision or AI can also count animals, detect disease, identify unusual behavior in the animals, and then monitor significant activities as like giving birth. And then this AI system or computer vision also able to collect data from cameras and drones, and then combine with other technologies to keep farmer informed on animal health and access to food or water. Like when in the chicken farm, the drone or the camera or the CCTV able to monitor the chicken behavior. So when the chicken have particular behavior, it able to tell that this chicken is healthy, this chicken is having some disease. So this kind of monitor is very helpful for the farmers. And then come to AI with healthcare, right? So with AI is getting sophisticated at doing what human do, and more efficiently than human and more quickly and with lower cost. The potential for both AI and robotics in healthcare is quite promising. Just like in our everyday life, AI and robotics is also increasingly a part of our healthcare ecosystem. So apart from it, AI in healthcare playing the vital role in keeping well. So what it does, once AI can be the biggest potential benefits. It will help people to stay healthy so that they don't need a doctor, or at least not as often. You can use this AI on the Internet Medical Things (IoMT) in consumer health application, which helping people. So you have like a AI system where able to consult and give suggestion to the patient, like what is the medicine that need to be taken, what kind of lifestyle you need to follow in order for you to prevent or inhibit certain disease. And AI also help in early detection. This is crucial for cancer, especially because cancer is always detected at the late phase of a person life. So when it detected at the late phase, it can the percentage of the patient to cure will be lesser. So AI help to early detection or early diagnosis of cancer in a patient just by get an image of X-ray, for example, lung cancer. It able to accurately tell whether this person is having or potentially having cancer. Right. Apart from early detection of cancer, also cardiac arrest. AI able to tell or early detection of cardiac arrest. Because if cardiac arrest is predicted in or able to be detected early, you can save life. For example, the AI able to tell that in another 12 hours, this patient will have cardiac arrest. You might be asking how the AI know. Of course, we have certain data in order to train the AI system, especially cardiac arrest. You need to have the vital of the patient. You need to have the lab test of the patient. You need to have all kind of treatment that being accepted by a patient. So there's so many factors and so many clinical variables that need to have to train the machine in order for machine to have to do cardiac arrest prediction. And then we can go to treatment, or I can say end of life care. So as we are living much longer than previous generation, because perhaps this generation we have a lot of medicine to cure our disease. So we are dying in a different and slower way. So for example, like condition like dementia, heart failure, and also osteoporosis, and we can have a robot to help or AI system to help us in care about our life. Like for example, help us to give medicine, help us to consult and to tell us what is our condition, whether it's deteriorating or is becoming better, and especially it do carrying us like a personal doctor in a house. And for the research part, I can't say enough. AI help a lot of people, a lot of researcher in research. For example, like with NLP, natural language processing, the researcher don't have to go through all the journal, the type of treatment, and the experiment that has been done, and what is the outcome. With all this AI system, it able to summarize and give it to you in a very short form, and thus it speed up the process of developing vaccine. And this is why we can have COVID vaccine in the very fast phase. Is because part of it being helped by AI. They don't have to go through all the research, all the output, all previous experiment, because AI helped to summarize this and try to give out the related experiment or related information. And this is some picture to show you accurate cancer diagnosis. And we have early diagnosis of fatal blood disease. So beside of if you see AI in just on the form of clinical, we can see that AI also helping in the molecular level. Molecular level, like it go to the DNA and help to sequencing the DNA of a bacteria, of a virus, of human, and it able to tell that what protein will interact with other drugs, and it will inhibit the pathogenicity of a bacteria, right? So this is how AI play important role in a molecular level, helping to invent new vaccine or new medicine. Because last time, if you want to have a medicine to mature in the market, it take about 25 years. But because of AI, it shortened the phases and shortened the time taken in order to produce medicine. And we have customer service chatbots. It's able to give you advices like a doctor. And of course, when you train this customer service chatbot, you don't train with one doctor. You train with a few information fed by maybe 20 doctors. So you have like a 20 doctors' brain being compact into one system, and the system able to chat with the patient and give advice. We have virtual health assistant treatment of rare disease as well. And then targeted treatment, as I said to you, the molecular level, like they're able to tell which site of the bacteria that you need to attack with drugs so that this bacteria will die in your body. So AI can help that. And the new version of AI will be the robot assisted surgery. So this is like a new advanced thing where robot assisted surgery has gained a lot of popularity recently. So several hospitals are implementing robotics that assist them in completing tasks that require precision, control, and also flexibility. It is used in tasks including like open heart surgery, exceeding this robot actually have exceeding human capabilities, and this robot normally it integrated with mechanical arms, cameras, and it require surgical instrument augment that like the knowledge, skills, and experience of the doctors. And this surgeries that are assisted by AI implemented robot result in less complication and is comparatively lesser pain for the patient, and it also result in faster recovery rate compared to the traditional surgery by doctors. Last for today, we have seen AI, machine learning, and deep learning. But to implement AI or machine learning, deep learning, it's not just implement it for the sake of implementing. You need really a great deal of AI, I can say AI hardware and software, and then you need a personnel who are expert in it, and then you need a lot of maths and Python code that's actually very complex to hold this machine learning to execute whatever outcome that you want. So most of the company, they think like doing machine learning is just like picking up fact, or pull the fact from thin air, without the data. Just like, oh, I have machine learning, I have few data, why not just do use machine learning to get to take the insight. It doesn't work that way. You need large data, and apart from it, you need label data means annotated by human, and then only you'll be able to tell that whatever you train to the machine or the algorithm is correct, because your human have verified all the data, and this is the desirable or example of output, and then you teach the algorithm, and then the algorithm will be able to use whatever you teach it to for future prediction or to forecast for the future. So that's all for today. Thank you guys. I hope this sharing will help you guys, or I can give some no I hope that sharing give you some information on.
Thank you so
Yeah.
much, Surendran. I have to say that this is really a very in-depth overview of AI. There were actually some use cases that I didn't even know about, and I've been in this domain for a very long time. So I actually find that it's a very useful, very inspiring presentation. We are almost out of time, but I did see a couple of questions come in. So let me project those. One of the questions is kind of referring back to one of the topics that you started with. And that question is, what is the line to divide strong AI from weak AI?
What is the line to, okay, what is the line? Okay, what is the line that divides strong AI and weak AI? I can say that the line would be like strong AI will be imitating like human, it able to have emotion, like it able to revenge if you do, if you give something work which is you don't like, then you're able to manipulate the work and make you suffer. So that will be strong AI. And big AI is just following whatever information that you give. Whatever, like when people say that AI will take over the world is actually is myth, because we did the machine learning, we do the programming, and over time, if you in machine learning, the machine will produce output which is not really good. So you need to train it periodically in order to have a good output. So I think that's a bit answering your question.
Absolutely. Then, as a host, I kind of have always the opportunity to also ask one more question. We really do need to stop in 3 minutes. That's a hard stop that we have. But very quickly, in the previous session, we had a speaker from Aeroline. And you're probably familiar because it's a large Malaysian company, and they have those drones with which you could measure the examples you showed in the presentation around measuring cattle and all kinds of ways in which you could do that. One of the main topics that came up in that presentation is, where do you draw the line in terms of ethics? And with AI, I basically know that that's going to be a discussion we can have for hours. But in your professional opinion, just can be a very short answer. Do you think that machines will ever be able to reason at the same level of ethics that people can?
Okay, that could be a discussion the whole day. Yeah, for me, I think that it wouldn't be, it wouldn't have the ability to have the empathy, or what just now you mentioned. The machine won't have that, because it is being programmed. So whatever we want to show, whatever we want it to produce, it will produce, right? So yeah, it won't have any extra feelings or any extra ethics. You won't have any all the moral values in order to do the decision. It just follow whatever it has been programmed, like 1 or 0. That's all. There is no 1.5, there's no 0.2.
Good. Good. That's a great way, I think, to end this discussion today. You've been an excellent presenter. It's really a pleasure to have you here at Big Data Days, even though it's the first time that you're on the conference. I hope you had fun as well. I see in the chat people say it's amazing and informative session, so you get a lot of very positive feedback, and I can only second that. So thanks so much for being with us on the program today, and I hope to see more from you in any of our upcoming events.
Thank you so much. Thank you for the opportunity. Great.
Absolutely. Our next speaker is already waiting. So for the people who are in this track, this time you don't need to make a choice, because in the other track there's a 2-hour workshop going on, which is entering its second hour. So what we're going to be doing in this track is that we're going to be listening to a very educated gentleman from South Africa, Mr. Nkosi Samba, who is the executive head of Big Business Data Insights at Medscheme Holdings, and he's going to be talking about value-driven perspectives to big data, combinatorics, and permutation implications, which I'm pretty sure is going to be a very amazing session as well. So we'll start again in 10 minutes, and I look forward to seeing you back in our next session. Thanks, everyone.